Hello everybody, welcome to the Python math section. In this video, I'm going to show you the way to prove whether a number is an Armstrong number. So what is an Armstrong number? So when we have a number in which the sum of all the digits raised to the power equal to the number of digits will be returning the number itself, then we say that the number is an Armstrong number. So we can see an example here. Suppose I have 371. Is it an Armstrong number? We can show it in this way. 371 is a 3-digit number. Okay, so when we do the operation as follows, we can say that we can get the same number. So what is the operation? We separate the digits and then we just raise the power of each of the digits to the number which is equal to the number of digits. So since we have 3 digits, we just raised each of the digits to the power of 3, and then we just add up all these powers. And in this case, we will have 27 plus 343 plus 1, so that this sum is equal to the number itself. So in this case, we can see that 371 is actually an Armstrong number. So the algorithm of finding out an Armstrong number is as follows. We have to save the digits into a list, and then we just raise the power of each of the digits, and the power is equal to the number of digits in a given number, and then we just sum up all the powers to see whether that number equals the original value. So let us see an example here. Suppose we go back to 371. In this case, we have to handle that number first, and then I just get the remainder of 371 divided by 10. So I will get 1 as the remainder. And then I just put 1 to the list that stores each of the digits. And then I just remove the rightmost digit so that I will be able to handle the next digit later. So 371 divided by 10 gives me a quotient of 37. So in this case, 37 will become the next number to be handled in the next iteration. Now we handle 37 in this iteration. We get the remainder when we divide 37 by 10, so I will have 7. In this case, I just put 7 into the list that stores each of the digits. And then I want to remove 7. How can I do that? I just get the quotient of 37 divided by 10. So I will have 3. And this value will become the subject of the next iteration. Now we handle 3. So when we do the remainder of 3 divided by 10, I will have 3. So in this case, I just put 3 into the list. And then, after putting 3 into the list, I can simply remove the rightmost digit by doing the division 3 divided by 10. In this case, the quotient is 0. When the quotient becomes 0, it just means that the iteration can stop. And in this case, all the digits are already saved in a certain list. Now after I have got the digits, I just do the power of each of the digits. So I would just raise 1 to 1 to the power of 3, 7 to the 7 to the power of 3, and 3 to 3 to the power of 3. Why do I need to put 3 as the power? Because 3 is simply equal to the number of digits in this list that stores the digits, okay? So after getting the powers of the digits, how can I continue? I just add up all the powers to get back the number at the beginning, which is equal to 371. So in this case, we can see that the Armstrong number is shown according to the previous algorithm. Now, let us see the implementation. I have to accept a number from the input first. Since I want to remove the rightmost digit in each of the iterations, I have to save that number to another variable so that I can simply do the removal more safely in order to remain the original number untouched. Okay, and then I need to set up a list to store the digits. So I first initialize an empty list, and then I can do the iteration as follows. when the number is not equal to 0, I can simply pick up the rightmost digit in each of the iterations. Okay, I can simply get the remainder when I divide the number by 10, which is giving me just the rightmost digit in each of the iterations. And then I just append that digit into the list that stores the digits. Okay, and then I can simply remove the rightmost digit as follows. When I do the division, I just get the quotient so that the rightmost digit is removed. Then I'm able to just get the digits to be stored in the list. And then how can I handle the list after getting all the digits? Let me show you now. Okay, I'm using the list comprehension technique to help me generate the numbers that are the powers of the original numbers, and then I just store those numbers in the original list. And then I just store the number in the list, and then I can simply sum up all the powers by using the sum function. Okay, so for each of the digits in the original list, I raise the power by the length of the digits list. So if the number has 3 digits, the length becomes 3. Then I will just raise each of the elements in the list to the power of 3. On the other hand, if the digit has 4 elements, I will raise each of the digits to the power of 4. And then I just sum up all the powers by means of the sum function. Okay, then the generated number is found, and then I have to compare it with the original number. If the generated number is equal to the given number, I say that I have an Armstrong number. Otherwise, I just say that I don't have an Armstrong number. Okay, now let me play with the program. If I enter something like this, oh, I got an error here because I didn't put the equal sign here. So my intention is to update the number copy variable with the number after dividing it by 10, so that I just remain the quotient to be the new value of the number copy variable. So this is the place I missed. I missed the equal sign to do the assignment statement. So let me try to play again. Now I just entered 1634, and I'm able to say that it is an Armstrong number. The reason is that there are 4 digits, so I'm able to calculate the sum of the powers as follows. So I'm just able to do the calculation as follows. 1 to the power of 4 plus 6 to the power of 4 plus 3 to the power of 4 plus 4 to the power of 4. I'm able to get the number back. So in this case, I'm able to say that the number is really an Armstrong number. So the program is quite easy to understand. I just follow the algorithm in the previous slides, and then I just use a while loop to do the iteration so that all the digits in the given number can be put into the digits list, and then I just do the operation of the powers according to the length of the digits list. And then I just sum up all the powers to get the generated number, and then I just check whether the generated number is equal to the given number. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.